So hello friends, welcome to my new video. So today in this video I'm going to discuss with you all about a very important topic that we all should know, that is about duochrome test. So in duochrome test, from this name we can easily understand that there is two colors are taking participation. One is red and another is green. So in this screen you can see this is red and this is green. So this duochrome test is based on chromatic aberration. It is a subjective test to assess the spherical endpoint. So in this video I will tell you how this duochrome test is actually working. Okay, so I am showing you the duochrome screen. So this duochrome screen look like this, where it is having a red background and also a green background, and you will show this screen to the patient monocularly, and if the patient say that green is more clear than red, it means that the patient is having hypermetropia, and if the patient say red is more clear than green, it means that the patient is having myopia. So how it happens, that I am going to discuss. Okay, so suppose this is your eyeball. Okay, and in case of emmetropic patient, what is happening is that suppose this is the red wavelength is coming and it is getting focused behind the retina due to the longer wavelength. Okay, and green, this is the green wavelength, it is getting focused in front of the retina, and there is another wavelength that is yellow. So this yellow wavelength is having 570 nanometer, that is getting focus on the retina. So here is the circle of least confusion. Okay, where the red and green both are not getting focus on the retina, but yellow is getting focus on the retina, where circle of least confusion is there and the patient can see properly. This is the case of emmetropic patient. So what will happen in case of a myopic patient, that I am going to tell you. Okay, so in case of myopic patient, from the definition what we understand is that light rays are getting focus in front of the retina, but red color or red wavelength is having a longer wavelength than green. So in emmetropic patient, the red wavelength getting focus behind the retina, but in case of myopic patient, this red wavelength will get focus on the retina. So it means it shifted from backward to forward. Okay, so let's draw this line is nicely. So this is the focus, and so that the yellow, this yellow wavelength will get focus in front of the retina, and green will get focus in front of the retina, so that the patient will see the red background letter more clearly than green, because the red wavelength, we can see the red wavelength is getting focus on the retina. Okay, so to correct this thing, we need to place concave lenses. Okay, concave lenses, so that this concave lens will actually diverge the light rays. Okay, that means after getting diverged in the cornea and lens, it will again get converged, so that the red, so this red will get focus over this area, and yellow will get focus uh, on this area. Okay, and green will focus here, red is focused here. So it will lead to equal appearing of both colors, the red and green. Okay, and that is the neutral point. Okay, now what will happen in case of hypermetropic patient? So in case of hypermetropic patient, from the definition we know that light rays are getting focus behind the retina. So in emmetropic patient, the green is getting focus behind the retina. So in hypermetropic patient, the green or sorry, the red. In emmetropic patient, red wavelength is getting focus behind the retina. So if the person is having hypermetropia, this red wavelength will shift more backward. Okay, and yellow, this yellow will get focus behind the retina, because in emmetropic patient it is focusing on the retina, but as the patient is having hypermetropia, it can be due to axial hypermetropia or curvature hypermetropia, the ray or the wavelength that earlier getting focus on the retina is now getting focus behind the retina. Okay, and here now green will get focus on the retina. Okay, and then the patient will say that the green background letters are more clear than red. So in this condition, what we will do is that we will place convex lenses. So this convex lens will ultimately converge the light rays more. It means that this red will come little forward, so that yellow will also go little forward, and yellow will get focus here, and green will focus here, so that the patient will say that red and green both background are appearing clear. Okay, so this is how it is done. So here this picture is saying that same thing that I discussed in that diagram. So here if the patient say that green is more clear, that means the patient is having hypermetropia, because red and yellow are getting focus behind the retina and green is getting focus on the retina. So he will see green is more clear than red. And if the patient say that red is more clear, that means these two wavelengths are getting focus in front of the retina and red is getting focus on the retina. So it means that red will appear more clear than green. So in this to correct this thing, that whether the patient is having myopia or hypermetropia, you need to add if the patient is having hypermetropia, where he is saying that green is more clear than red, so you need to add 0.25 diopter or plus 0.50 diopter steps. Okay, in these steps you need to put the power, okay, until the patient say that both colors appear clear, equally clear. Okay, and if the patient say that red is more clear than green, then you need to put minus 0.25 diopter or minus 0.50 diopter steps spherical power until the patient say both background colors are equally clear. Okay, so this is how you will do this duochrome testing. Okay, and this duochrome testing also used to see the over correction or under correction of the patient. Okay, so that's all friends, thanks for watching. Please don't forget to like my video, subscribe to my channel. I hope this video helped you a little bit to perform the duochrome testing. Okay, so all the best.